a rising sophomore at the Urban School of San Francisco, and today I'm going to be presenting to you my automated solar tracker. So these solar panels will turn toward where there's more light, so if I shine my flashlight here, turn that way, almost 180 degrees, shine over here, turn that way. Right now, this is at a fairly neutral angle. It's great for the summer, but in the winter I need a deeper angle to match the same efficiency. So I have a system of bolts over here. If I just loosen these up, I have up to 1 foot of adjustability. I can drop this down further than that if I want. And basically what that allows me to do is get the most out of these panels. So not only do they autonomously rotate, but I can adjust that however much I want, like every week. So basically the two key components of this system are electrical and mechanical. So basically how the mechanical works is those bolts go up and down to change the angle. But because those bolts go up and down, if they go up, this side, this support here must go back. But if they go down, the support must come forward. So I have bearings inside of here to make sure this has smooth rotation. But also the motor itself also needs to rotate to stay perfectly in line with the angle of these panels. So I have this motor mount itself on a hinge to make that fully adjustable. And as far as the electrical system, there's 4 photoresistors or light sensors on each corner of the panel. And they will send a signal into the Arduino, which is a microcontroller. And that microcontroller will take that signal, read those values, and if there's significantly more light, it will send a signal into the motor controller. So that motor controller determines the speed and direction of this motor, telling the panels where to turn, and they will turn wherever there's more light. So that's basically the electrical system. And then of course there's a solar panel, feeds straight in 30 volts, about 60 watts in full sun, right into that Goal Zero 400 battery right there. So this is very challenging for me because despite the fact that I have previous engineering experience, I've actually exhibited at the Bay Area Maker Faire 3 times. I don't know if any of you guys have been there, but in those projects I had a team where here I was alone, had to make my own original design. Of course I had the help of BlueStamp, but it was definitely more difficult in that respect. But the real challenge was actually the coding, because for each of these LUT sensors, I had to make a separate variable in my code, and I was really unfamiliar with Arduino, so that was a real challenge for me. But I felt I was ready to take it on. BlueStamp helped me along the way, little steps, and I could really start developing my coding skills, which I want to continue with in the future. So as far as the future of this project, I'll probably make a couple modifications, make these light sensors be able to disconnect on the little connector here so I can store it better. Maybe make these stronger, these shadow shields, just make sure that the sun is really truly on one side for it to be able to turn. But as far as past that, I'll continue with projects like this. For example, a stand-up electric scooter I made. And as far as college, I'll probably want to go to renewable energy, earth sciences, and continue developing my skills there. Maybe we try to power a car on plants if I can, I don't know. All right, so thank you guys for listening.
Home-based? Would it be industry? Would it be large-scale, large-scale, small-scale? Where do you see this fitting in?
Well, it could really be any scale. I'd say this is the smallest scale I want to go. I think this would be great for households. You just put it in your backyard. Battery, you can charge up your phone like 30 times, tablet 10 times. So great for charging your small electronics and saving a bit of power there. But as far as industry, it could definitely be larger scale. Get larger solar panels and maybe even put something like this on top of a house to make sure you'd be able to get the most sunlight. So it certainly has more applications than just a small household. Yes?
What kind of gains in efficiency do you get from the panel falling to the sun as opposed to the panel being in a fixed position?
Well, if it's in a fixed position, I would probably fix it just like this. I don't know the actual percentage gain, but if the sunlight's coming down here, of course it goes across the sky, so if this turns, it's going to be hitting more the center of the panel. And the more direct the light is, the more watts I get out of this. So I maybe, if it was like here, I could maybe get 60 in the middle of the day, but then it would drop to like 20 or 10 in the later hours. But maybe I could get like 30 or 40 watts instead if it's turned directly towards the sun. Yeah.
If you had some more time, could you automate it turning, like going up and down?
Yeah. Yeah, that would take a lot more power, but it's definitely possible, yeah. The Arduino could certainly provide controls for that. And I probably wouldn't have it, I'd probably set a schedule for all the seasons. But yeah, sure, you could have some kind of motor racing those bolts up and down.
We just can't see it. Is the Arduino behind the battery?
Yeah, I can actually remove this really quickly. Just to see what's behind here. Oh, 3. Arduino, circuit board, motor controller, 3 main electrical components. Any other questions? All right, thank you.